In December 2023, customer walked away with brand new Chevrolet Tahoe for $1. Chatbot sealed the deal in less than 2 minutes. You might be thinking, that's a problem of big corporation. Wrong. Same engine which powered Chevrolet Chatbot is powering your automation. If you don't understand why this happened, it might happen to you. My name is Tomasz, 10 plus years solving logistic problems at a Fortune 500 company. Today, I share the framework I use to automate without breaking what already works. By the end of this talk, you're gonna understand why it happened, why it's not going away, and what you can do about it. Here is what we're going to cover today. First, I'm gonna explain why LLMs behave in this way. Next, I'm gonna show you a case study where an airline lost money to the customer, and in the end, I'm gonna show you 3 simple techniques which you can implement today to protect your business. To understand why Chevrolet Chatbot say yes to $1 deal, first we need to address 2 terms, probabilistic and deterministic. Deterministic means same input, same output. If you think about Excel formula running over the same variables, it always gonna give you the same results. Doesn't matter if you're gonna do once or 10,000 times. The result is always the same. Probabilistic mean same input, different result. You can think about your GPS device, which today is gonna give you 25 minutes of traveling time, and tomorrow on the same road, maybe it will be 23 or maybe 24. It's not giving you calculated results. It's giving you prediction based on the patterns. So, if LLMs doesn't follow rigid rules, what they actually doing? Everything starts with token. Token is the basic unit of text which LLM can process. We people read text in words. LLMs read text in chunks. These chunks are called token. Roughly speaking, one token is around 3/4 of a word. So when you typing 100 words prompt, LLM see this as around 130, 140 tokens. Why does it matter? Because LLM doesn't think as we do. They do not reason as we. What they do, they predict the most probable next token and where it's getting interesting. Here is the key insight. LLM don't think. They predict. To be specific, they predict the next token. Here is an example. When you type in the cat sat on the into the text window and expect LLM to finish the sentence, LLM doesn't think about cats or sitting. What it's do, it's predicting the most probable outcome after the word set on. It calculates probability. Mat get 60%, chair maybe gets 40%, and roof gets 10%. And here where it's really getting interesting, because it doesn't always pick the most likely token. There is something called temperature, which introduces controlled randomness. Temperatures in LLMs can vary between 0 and 1. Temperature closer to 0 means that model behaves more deterministic. Most likely the top peak always will be chosen. If you're gonna set a temperature close to 1, model gets more probabilistic. It's more creative. In this situation, it's quite probably that model gonna pick the second or the third peak. Why not to pick always the top token? Because it's gonna produce boring and robotic text. Controlled randomness makes LLM feel more human. It's not a bug, it's a feature. So from where all of this randomness is coming from? It's coming from the training process. Modern LLMs are trained at enormous amount of text. Through the training process, model start recognizing patterns. When you talk to LLM about cats, it know that cats like to sit on humans or at PlayStations. That's how ChatGPT can deal with sentences which never seen before. It's produce outcome based on patterns and relationship, not from learned strings. We understand why randomness is a feature and why we need it. When you start using LLM in your business workflows, you might have a problem. Because from one side, you expect to have a natural sounding response, but from the other side, you also expect that these responses always will be true. How can you get both? Before I'm gonna show you 3 mitigation techniques, which are very easy to implement, I would like to share one case study. Some reports say that Chevy case was made up, but Air Canada, this one is real. This actually went through court and even Forbes covered it in a recent article. Here is what happened. In 2024, customer received an information from Chatbot that when he is traveling for a special occasion, in this case was a funeral, he can book a ticket and after that apply for a refund in next 90 days. They apply for a refund and they got denied. Actual Air Canada policy, no retroactive refunds. Bot made it up. Air Canada defense line, one, they said that Chatbot include also a link to the policy, so customer could double check. And second, they argued that Chatbot is a separate legal entity, not them responsibility. Court find it remarkable. Here is the point. Chatbots or LLMs never gonna inform you that they might be wrong. It's your responsibility to build in systems which might flag possible corrupted outcomes. Your bot, your website, your responsibility. We know what is the risk. Let's start talking how to fix this. What I'm going to do next is to walk you through 3 easy to implement mitigation techniques which gonna protect you, your business and your customers. Let's jump into the screen. Here are our 3 easy to implement mitigation techniques. The first one is self-consistency, majority voting. Ask the same question multiple times and see if you get the same answer. Next one, LLM as a judge. Can the model critique itself? Take the output from your first prompt and feed it into second prompt that asks the model to evaluate. And the last one, multi-angle questioning. Asks the same question in a different ways and checks if the answers still agree. Let's start breaking them down. The first one is self-consistency. The simplest way to increase confidence in LLM output is to ask the same question multiple times and see if you still get the same answer. Why does it work? Each generation involves randomness in token selection. But if the underlying pattern is strong, if the model really knows the answer, it will land the same results most of the times. Inconsistency means the model is guessing. When should you use it? It's ideal for classification tasks or yes or no decision. For example, categorizing customer emails, extracting a specific data point, or validating whenever a statement is true or false. How it looks in practice. We're gonna use example of customer service and ticket routing automation. A customer emails in and you need LLM to classify it into one of the 4 categories: billing, technical, returns, or general inquiry. Step 1 and 2, create and run the same prompt multiple times. In our case, the email from the customer is, I was charged twice for my last order and I need a refund. Our task in this case is to classify this customer email into exactly one category: billing, technical, returns, or general inquiry. The output, which we expect, responds with only the category name, nothing else. Here is the visualization of which steps are we taking. First, customer email is coming in. I was charged twice for my order. Then we create our prompt and we're running this 3 times through the same LLM. In step number 3, we collecting responses of LLM. Run number 1, billing. Run number 2, returns. Run number 3, billing. As you see, LLM run 3 times and we're getting 3 responses. In our case, we're running this 3 times, but it really depends how complex is your situation. You can run this definitely more than 3 times to get a better results. In step number 4, we count and score. Our case is extremely simple. We get billing twice and returns once, and that's giving us the percentage of the responses. And here is step number 5, the most important one of the entire workflow. Apply the threshold. You set a rule. Only proceed automatically if one of the category hits 90% of higher. In this case, billing got the 67%, wrote the ticket for human review. Here is how looks the entire process in one view. First, customers is emailing us with the complaint. We're creating a prompt. We're running the same prompt 3 times by the same LLM, or maybe more if the case is complex. We're collecting the responses, we count them and the score, and we apply our threshold. In our case, the situation was very simple, and we're also talking about internal communication, so your threshold might be lower. If your workload is hitting customer directly, you might to set up your threshold higher than 90%. Let's jump into the second method, LLM as a judge. Can the model critique itself? You take the output from the first prompt and feed it into the second prompt that asks the model to evaluate, critique, and verify the response. Why does it work? Because generation and evaluation are the different tasks. Each step is simpler, fewer chances to get off track, error doesn't compound. You catch them early. Breaking into the steps is a known prompt engineering techniques which is called chain prompts. When it evaluates, it's comparing against the criteria you provide. The difficulty here is to define clear criteria. Example of this could be: does the response answer the question? Is the tone professional? Does the summary contain information not in the original? In our example, again, we're going to use a customer service situation. Validate a customer email draft. In step number 1, we're creating the first prompt. Write a professional response to this customer complaint about a delayed shipment. Be empathic, offer a solution, and keep it under 100 words. And here is the example of the email which we received from our customer. My order was supposed to arrive 5 days ago. This is unacceptable. I need it for my daughter's birthday tomorrow. So visualization, how this is happening. First, we getting a complaint from our customer. My order is supposed to arrive 5 days ago. And we create our first prompt, which is supposed to create a proposition how we're going to answer to this complaint. First run through LLM, generate this response. Dear customer, I sincerely apologize for the delay with your order. I understand how frustrating this might be. And there are some other information here. So again, we're getting a customer complaint. We're asking LLM to provide us answer to this email. Step number 3 and 4, judge prompt. This one is a bit more complex, so let me break this down. Evaluate this customer service email against this criteria. For each criterion, respond yes or no. Here are the criteria which we set. Is the tone empathic and professional? Does it acknowledge the specific issue? Does it offer a concrete solution? Is it under 100 words? And does it avoid making promises that company might not be able to keep? Next to our criteria, we insert the first email generated by the LLM. In this case, dear customer, I sincerely apologize for the delay. Here is the format we expect from the second run of LLM. For each criterion that we set, we expect answer yes or no. Next to that, we also want to receive an overall score. Pass if all answers are yes, fail if any answer is no. Next to that, we also gonna receive a one-sentence explanation if the try, pass or fail. So let's jump again into the visualization. Steps which we took so far. Customer email us with the complaint that order is late. We create the first prompt and we ask LLM to create a professional response to this email. This customer, I sincerely apologize for the delay. Next one, the critical part, we're creating a second prompt to judge this professional response. And we're fitting this again into the LLM for the second run. Second run of LLM give us this response. For each criterion that we set, we're receiving an answer yes, no. In our case, one of the answer is no, and the overall score is fail. Reason, the email promised delivery by the end of tomorrow, which the company might not be able to guarantee. Let's repeat the entire process once again. Customer email us with the complaint. We ask LLM to run for us the first response. Dear customer, I sincerely apologize for the delay. Then the critical part of this technique. We're creating a judge prompt. Based on our criteria, we evaluating the email which gonna hit the customer. And in the second run of LLM, we ask to evaluate if our response is good enough to hit the customer eyes. The last step of this process is to compare the results. In our case, we fail because our response to the customer promised something which company might not be able to deliver. In this case, I would suggest to go first to the first prompt and set some strict criteria. For example, add a note, please do not promise the delivery the next day. And every time when you're getting a failed response, this gonna be hint for us how we're supposed to create a first prompt to avoid this situation. Last technique today, multi-angle questioning. Ask the same question in a different way and check if the answers still agree. LLMs are sensitive to phrasing. Small changes in how you word the question can shift the output. You can think about it as cross-examining a witness. A solid story stays consistent whenever you ask what happened next or walk me through the events. If the story shifts based on how you phrase the question, something is wrong. Example for this technique will be extracting a contract renewal date. You are processing the contract and need to extract the renewal date. One wrong date could mean a missed deadline. In step number 1, we create multiple prompts. 3 different ways to ask the same question. Prompt A, direct. What is the contract renewal date in this document? Prompt B, contextual. Review this contract and identify when it must be reviewed. Prompt C, negative framing. After what date this contract expired and needs to be renewed. Looking at the visualization, we have our contract. We create 3 different prompts. Step number 2 and 3, run all 3 against the same document. We have our contract. We create our 3 different questions and we're running this through the same LLM. LLM produce 3 different outcomes. The final step, compare the results. If all 3 matches, high confidence, proceed automatically. If one of the responses is different, flag for human review. The document might have unclear language, or maybe there is a distinction between renewal date and expiry date. Let's look at the entire process in one view. We have our contract, we have 3 prompt variation, we're running this through the same LLM, we're getting 3 responses. If we are lucky, the responses are the same, and then we're comparing the results. Again, how to address the situation when results are different? We're creating a different prompt, or we're working with the document and making the document more clear. We know our techniques. Let's compare pros and cons for each of them. Self-consistency. Ask the same question multiple times and see if you get the same answer. Pros. Simple to implement. No special setup required and also easy to explain. What are the cons? Multiple API cost, slower response time, doesn't help if the model is consistently wrong. All runs can repeat the same mistake. LLM as a judge. Can the model critique itself? Take the output from the first prompt and feed it into the second prompt that asks model to evaluate. Advantages: catch the errors that single pass generation miss, flexible criteria, you define exactly what you want to check for, and the last one provides explainable feedback. What are the disadvantages? Blind spots might remain, add latency, 2 LLMs call instead of 1, only as good as your criteria. Vague questions gonna get you vague results. And the last one, multi-angle questioning, asks the same question in a different ways and checks if the answers still agree. On the plus side, expose fragile answers. If phrasing changed the result, you know not to trust it. High confidence when answers agree. Catch the lack of clarity of the source document. In general, it actually can help you to write a better contracts. And the cons, required effort. You need to craft a multiple prompt variations. In our case, it was very easy because we just work with the expiry date. But in case you have a more complex contract, it really might take some time to create these variations. Multiple cost and slower processing is basically the same disadvantage of each of these solutions. But from the other side, that's the way how you can get more trustable results. Last word, every method has holes. The trick, stack them so the holes don't line up. And for the most critical customer interactions, add the human in the loop.